Thank you to accepting to share my work with you.
Thank you very much.
I'll start to sharing my screen with you.
Okay.
Today, I am going to talk about design of reconfigurable antenna for WLAN application.
Hello, everybody. The president of the session, honorable assistants, good morning. Thank you for coming to show my presentation. My name is Mr. Garah. I am an assistant professor from the University
Where
of
is this?
And I will talk about dual band purpose.
Okay. Somebody must be mute. Just a moment. I will mute all this. Guys. Okay. Now I think that everybody is now mute. Continue, please, Rima.
My name is Rima Sariour. I am a PhD student from University Msila from Algeria. Today I am going to talk about design of a reconfigurable antenna for WLAN application. I divided my presentation for 6 parts. Firstly, what
as
is
an outline, the presentation is scheduled as follows. We will start with some definitions concerning the power dividers. And
Rima, is somebody with you?
With their applications will be given.
Is it somebody with you? Who?
Yeah.
Please tell him that don't talk.
As a result,
Please tell him that finish talking.
Power divider will be illustrated. The power divider can become the power.
Please start from the beginning, Rima, and say somebody that which is with you that don't talk with you because we are heard this.
Yes, I'm sorry.
Okay, sorry, stop. Just continue from the beginning. Yeah.
I divided my presentation for 6 parts. Firstly, what is the reconfigurable antenna? Some examples of reconfigurable antenna using pin diode, antenna designed, switching method, and antenna simulation. Finally, conclusion. Let me move to begin with what is the reconfigurable antenna.
As an important facet element in microwave systems, which is widely used in antenna array feeding.
I'm sorry, just 1 minute.
Also,
Give me just 1 minute.
Power amplifiers and mixers. We note here that this device can be used as combiner or splitter.
Please continue. Continue, Rima.
Just 1 minute.
Okay. Put mobile phone off here. And continue. Please. Okay.
What is the reconfigurable antenna? The reconfigurable antenna is an antenna capable of modifying its frequency and radiation priority dynamically. To obtain a dynamical response, a very popular common method is to use RF switches, varactor, mechanical actuator, or tunable materials to introduce the variation in the current distribution. There are 4 types of reconfiguration. Firstly, frequency reconfiguration. Adjust dynamically the frequency of operation. Radiation pattern reconfiguration is based on the intentional modification of the spherical distribution of radiation pattern. Polarization reconfiguration are capable of switching between different polarization modes. Component reconfiguration is the capability of simultaneously tuning several antenna parameters for instance frequency and the radiation pattern. In the second part, among the reconfigurable frequency topology, RF switches. A common method for constructing a reconfigurable antenna is to use RF switches to connect the different parts of the antenna by opening and closing these switches. The current is directed in the way it alters the antenna radiation priority and impedance. The RF switches may be mechanical or semiconductor. Some important characteristic of switches are characteristic impedance. And the switch is non-reactive. It is the matched to the transmission path. Otherwise, it is reflective. The bandwidth, some switches are low pass filter, while the others are band pass filter. Insertion, loss and isolation, the relation between the switches output and input powers when the switches is on and off respectively. We take and semiconductor switches like a pin diode is used to obtain a frequency reconfigurable antenna. The fraud based in a pin diode creates a very low resistance at a high frequency, while reverse Bayesian results in the opinion circuit. In this slide, we show the pin diode. It has heavily depot at P-type and N-type region. We use this element for create a reconfiguration antenna. The advantage of pin diode, a lower cost, a short switching time, and a high safely voltage. Now we give some examples for a reconfigurable antenna using pin diode. Here in this antenna, we using another type of pin diode representation in simulation by a pack pad and we have another examples of reconfigurable antenna. Combination of 5 elements radiation using a pack pad method to achieve the reconfiguration. Now let me move into antenna design. The proposed antenna is designed on a low-cost substrate, which has a relative permittivity epsilon R 4.3. We made the patch and the ground by copper. The antenna give me two WLAN application frequencies, 2.4 gigahertz and 5.2 gigahertz. The pin diode preferred switching method. This is my design of antenna. The radiation structure, which is made up of the slot, is cut at the upper portion of the rectangular patch, a L-shaped slot and the microstrip feed line. And the radiation element was packed by metallic truncated ground plane with the two square lobe. Slot is etched below the dielectric septa to provide the optimum efficiently and gain and the directivity. To access the reconfigurability, we include the pin diode in the structure of antenna. We presented in two states, in the off state and off state. In the on state is represented by the metal strip, and off state is represented by the absence of metal strip. Let me show the simulation results. This antenna appears a good return loss at 2.4 and 5.2 gigahertz. The surface current for two frequencies, the surface current distribution of the radiation patch also changed, which demonstrated how the reconfiguration affected the current distribution on the edges of the patch. We show the result of the radiation pattern in A-plane and H-plane for proposed reconfigurable antenna. Radiation pattern is shown indicating an omnidirectional radiation pattern for two cases. Let me summarize my work in the conclusion. A reconfigurable antenna has been presented and discussed using a pin diode. The objective of our work was the design of a frequency reconfigurable antenna. To achieve the reconfigurability, we use the pin diode included in the structure of antenna. This antenna was designed with two different frequencies to operate from 2.4 gigahertz to 5.2 gigahertz, depending on the on or off state of the pin diode. These two bands are used in WLAN application. Thank you for attention. Have you any question?
Is any questions? Does anybody have some question? Okay. We're going to next. I called the Kamal Siheri, which wasn't on the third places because I have one answer from him. He wasn't when was we started, to waiting to be somewhere in the end or in this program. If Kamal is here, to call me or to send me the message. The next is Guarayan Rania. Is it good pronounced?
No, Garnin Rania. Hello.
Garnin
Rania.
Garninania. Okay, yeah. Thank you. Thank you. I learn every day something new.
Yeah,
okay. the Rania is come with the design of efficient 2.45 gigahertz single band Rectina system for ASM application.
Yes.
Please start your presentation. You have 15 minutes. Care about these 15 minutes and start.
Okay, thank you. Hello, everybody. First of all, I would like to thank all the members of the conference who give us this opportunity to discuss and to talk. I am Rania Garni, PhD student at University of Mohammed Boudiaf, Msila, Algeria. Today, I'm going to talk about the design of efficient 2.45 gigahertz single band Rectina for ESM applications. As an outline, our presentation is structured as follows. First of all, I'm going to give you some view about harvesting energy system. Then I'm going to give you some information about Rectina and their characteristics. After that, to evaluate the performance of our circuit, some study must be done. Then, at last, some concluded point must be taken. Like we see in this figure, the energy harvested market is witnessing continuous growth, where the market size reaching up to 706.92 in 2023. Then it expected to reach more than in 2033 to $1829.27 million. It means that there are people investing in order to harvest the energy. The question here, what mean by harvested energy and how we can harvest this energy? Harvested energy is the process to producing electrical energy by capturing the energy from the environment, from the renewable energy. This technique is very important in order to power the devices, because the lifetime of traditional battery is very limited and it's very toxic. This figure shows the renewable energy. For example, solar energy using photovoltaic cells, magnetic vibration, and thermoelectric energy. Also, we have radio frequency energy. In our work, we are going to use radio frequency energy. This energy is it's variable in the environment with a huge amount because it comes from communication networks. For example, satellites, Wi-Fi satellites, or digital TV and others. Also, it is available or present with in all days and in all times. It's mean in all conditions. Also, with this technique, we can avoid RF pollution. It means we can avoid interference with electromagnetic waves. Also, the health of the people became more safety. The question now, the answer of the second question is how we can harvest this energy. The answer is this system is use Rectina device. The main goal of this device is to convert in RF radio frequency energy into DC voltage. Like figure 3 show, the Rectina system or Rectina device consists of 3 imported elements, receiving antenna which collect electromagnetic waves from the environments, and rectifier block based on a Schottky diode, and matching impedance placed between them to ensure the maximum transfer of the energy from the sources to the load. To evaluate the performance of this device, we must evaluate two quantities. The first one is DC voltage level, and the second one is RF-DC conversion efficiency. These two performance, or these two quantities, are dependent on input power level and sensitive for the frequency change. It's mean when we have input power level, different input power, and when we have frequency change, here we have mismatching and increase or decrease in the efficiency. The proposed design of the Rectina system is presented in this slide. The main circuit consists of two sub-circuits. The first one here, and the second one is presented like this. The first sub-circuit is the impedance matching. This circuit consists of passive element, inductor and the capacitor. These two elements, the value of these two elements is tabled in the table 1. And the second circuit is the voltage doubler configuration based on a Schottky diode. Here we use HSMS 7630 model. Now we pass directly to see the results. We start with the input impedance. The input impedance is calculated using Z-in simulator in ADS. This result is very important, like I told, that it is ensure the maximum transfer. And the second one, as mentioned, figure 6 as mentioned, our circuit is operated at 2.45 gigahertz. In this figure, or in this slide, the figure represents the efficiency of the proposed circuit versus the input power and the load resistance. As mentioned in figure 7, the efficiency has been increased between the range from -20 to 0 dBm, then decreased until 20 dBm. The peak value of the efficiency of our work or of our circuit is up to 17% at 0 dBm and at 5 kilo ohm load resistance. And the figure 8 shows that the efficiency is increased rapidly, then decrease after some value of the resistance, and the optimal value of the peak value of the efficiency at the optimal value of the load resistance is up to 17%. Also, the simulated output voltage level of Rectina versus input power and load resistance are represented in this slide. It observed that the DC voltage increase with increases of the input power as well as the increase of the load resistance. An optimum output voltage is equal to 1.5 volt is achieved for a load resistance of 5 kilo ohm and input power equal to 0 dBm. As a conclusion, a single band Rectina has been presented and discussed using voltage doubler topology. The goal of our work was to design an effective single band Rectina operate at 2.45 gigahertz and dedicate for ESM applications. To achieve this goal, a study of Rectina circuit was conducted using an ADS simulator. Simulation result using ADS simulator showed that the proposed Rectina is capable to harvest energy at 2.45 gigahertz and has a potential application in ESM application. As perspective, this project can be improved by designing the same circuit for dual band or change in input condition. It means we can change the load value or input value to increase the efficiency and to increase the output voltage. Here we have some references, and thank you for your attention. If there are any questions, I'm happy to answer. Thank you.